Okay, I'm just going to post the link to some chats and then we'll get started. Let's tell people on the internet where this is, what's happening, the URL so people can get on board. So go, copying it off there, paste it to Facebook, paste it over to Fortune DIY, and I think that's a good start for now. Paste it over in Synth DIY as well. Maybe you can get there right now. All right, you can't. So let's get started. All right. Live electric construction. It's digital ones based on generators. So they use no batteries. Here's a typical generator. It's actually a couple of stepper motors connected by. And to play the instrument, you drag the belt like this. And if you didn't already know, the voltage that comes out of these stepper motor generators is AC. So we have to turn it into DC because that's what synthesizers run on. So there's a real simple circuit. This is an old one I built a long time ago before I designed a PCB. And this is the new PCB. So most people would use a bridge rectifier to turn AC into DC, and that's a perfectly fine circuit. Tell you what, let's get the microphone going here. It's a little better. Yeah, how about that? So this circuit is actually called a AC doubling rectifier or voltage doubler. That's because let's say you have like a 10 volt AC signal peak to peak, then a whole bridge rectifier will give you a nice 10 volt signal peak to peak, but the voltage doubler will actually give you a 20 volt. Why is that better? Because part of the electric eels have an amplifier in them, and amplifiers almost always run better with higher voltages. So I'm very excited because for many years I was just making these circuit boards with what do you call it? Laser cutter technology. So this whole thing is laser cut, all the holes, the perimeter, and even the writing, and even the way you're supposed to make it is all scribbled on here with the laser cutter. It's etched. And I was trying to be excessively environmentally friendly. And that's a good impulse, but it's not too practical. So now I've actually gone to Osh Park and had this PCB made. And they just arrived a couple days ago, and I've been very excited to come down to Framingham Makerspace and put these together. So let's talk about the components. A whole rectifier usually has just 4 diodes in it, a whole bridge rectifier, and 1 capacitor. The voltage doubling rectifier, and I'm sorry I don't have a schematic here for you, but if you just Google or DuckDuckGo voltage doubling rectifier, you'll totally find a circuit for it. So this one, it actually uses 2 capacitors. That's part of how it gets the higher voltage. You'll notice these are humongous capacitors. These are so big that they don't just have those skinny terminals. They have these evil, strong terminals that look like talons on them. And they have a pretty large voltage. These are 50 volt capacitors. 50 volts is, I found it's necessary because sometimes these generators pump out at peak quite a lot of voltage. So it's good to have more voltage than less. I've actually shorted out capacitors before that were only 30 volts. So now I'm not messing around. The only penalty you pay is a little bit of size, and they cost a little more. And then the actual capacitors themselves, these are 4,700 microfarads. So I think I did a calculation once, CV squared, and I think a 3,325 volt capacitor could hold at max around a joule. I'm not going to stop the whole show and just do the math for you, but maybe in the comments or something. So these are double the voltage. So because you have that CV squared term in there, you're going to quadruple the potential power that these can store. And don't forget, you've got 2 of them. So just off the top of my head, I think that means that this can output 8 watts between the 2 of them for a single second. Or for a tenth of a second, could possibly output 80 watts. So this could, the circuit generally doesn't make quite that much power. I think the peak I've seen is maybe 25 watts. But it's nice to know that we have the extra capacity, so we know this isn't the bottleneck. All right, so before we get too bogged down in details, let's take a look at the circuit board here. So I'm going to step into the frame so we can see exactly what's going on. So right here is where the capacitors are going to go. You can see they're labeled with a plus. And then here's where the gigantic rectifier diodes go. So you can see they're labeled with their white band. And the white band actually corresponds to the diode right here. So they're just going to go in exactly like you see it there. All right, and then this is the spot where the terminals go. So I actually got some of the terminals out. And they're just going to go right into there. These are wire terminals. So you put your wires in there. Whoop, dropped it. They have so they got the screws in them. Yeah, see if we can focus on that. All right. And so this board actually holds 2 of these rectifiers. It's got, and that's because the stepper motor has 2 phases. So this is the so-called input side of the thing where the 2 stepper motor leads are going to go. And this is the DC side of it. So hopefully in the course of this video, we'll get everything soldered up. So hopefully in the course of this video, we'll get everything soldered up, and maybe we'll even get to test it in a circuit. I've been doing a lot of these live videos because I kind of enjoy the thrill. And most of the time we at least get something working, although a few times I've had some epic failures on camera. Fortunately, this is a simple enough circuit that I don't know if I don't think we'll we have a high probability of success, let's just say. All right. So first thing I'm going to do, just get the pliers out and bend the leads on these rectifier diodes. Oh, don't place them backwards, start to place them in. Notice that these are special rectifier diodes. I use these. I'll read you the part number for anyone who's interested in that. These are the 1N5822 rectifier diodes. Special thing about rectifier diodes is that they're designed to have a very small forward drop, meaning that they don't waste much voltage and consequently they don't waste much power. It's very important in any power supply to be as efficient as you can. In particular, with the electric eel generator instruments, you want to make use of every little bit of power that the person puts in, because you don't really have an excess. You know, it turns out we're kind of conditioned to think that electricity means infinitely large amounts of sound, but that's usually just because we're talking about a stereo plugged into a wall, or talking about like a car stereo. You know, the car stereo is the car battery that gets charged from the combustion engine of the car. So there's always an excess of power available. But when you have a human powering these things with their hands, in my experience, it turns out there's just enough power to make a loud enough sound. Depending on the instrument, the design of the whole instrument system, You could sometimes get to about 100 decibels, which is pretty good, but most of the instruments get around 80 to 90 decibels. So I'm always looking for ways to increase the efficiency. Speaking of efficient, I just realized I didn't even turn on the soldering iron yet, so let's give that a moment to heat up. But here you can see I've got the first couple rectifier diodes placed. As soon as that bad boy heats up, we're going to start soldering them. Let's see if we got enough right now. So for soldering, these are kind of thick leads if you look carefully. So I know they're going to take just a little while longer to heat up. I still like to keep my temperature around 650, 700, 750 degrees. So you know it's just going to take a little longer than usual to get these going. That's fine. So there we'll do a little tinning, do a little extra heavy tinning because I know got to get a lot of heat transferred. Warm up both parts, attach the solder, and then bam. It's a decent connection. I'm holding it on just a while longer because it's so thick. One other pro tip, when the leads are actually this long, they'll dissipate some of your heat and it'll take longer to solder. So sometimes I'll just pre-trim all these. Not necessarily trim them all the way, trim them halfway. Once they're soldered in place, we'll trim them off even more, but all right. So let's come in, let's get that bad boy. Heat it up again. There you go, spread that solder, hold it for an extra second. There you go, feeding it in there. All right, that's the first 4. Making perfect little solder tents out of these. Don't expect any problems. All right, there we go. Have a look. Now I'm going to trim them off all the way. See if I have a better pair of cutters in there. Yes, got the diagonal cutters. One of my favorite tools of all time. Okay, so next we're going to put on the terminals. So I need 4 of those. So those just arrived the other day. Let's get them out of the bag. Here we go. It took a long time choosing these terminals because I wanted ones that work with the biggest and the smallest wire and that are inexpensive. So if you look around in my wiki, you'll see like a zillion different places where I was researching the terminals to find just the right ones. Once you find a good component like that, what you want to do is keep track of it, you know, in a wiki or a spreadsheet or a notebook or something. And then you also want to keep track of 2 or 3 like it. Why? Just in case that one goes out of business or the price changes or they're temporarily out of stock or something like that. right, so I got my board upside down, just trying to get these little terminals. I decided to go the flexible way and get terminals in units of 2, even though I have 4 spots. So it's just a little trickier to lay them out, but I can totally manage. There we go, I'll tin the iron to start. I'm noticing that the eagle part for these is got a slightly wider diameter hole on the board than the terminals. Not that it really matters. It might just sit a little better if they're the same diameter though. Okay, that's the first 4. Next 4.
No. Sorry about that.
There we go. Burn through a lot of solder there, so we got a lot of smoke from the flux. Bam. Beautiful. All right. Did we get them all in the right direction? Oops. Keep doing that every time I sit up. Next time I sit up. So there we go. Oh, that's looking so beautiful. Oh yeah, okay. So that's 2 out of the 3 components now. We just have to put on 4 of these capacitors. Mega capacitors. So when you're soldering these on, it's pretty easy to see which side is negative. They got all the negatives on there. And the funny thing is that the board tells you positive, but the component tells you negative, so you have to use a little bit of inductive logic there. Hope most people get it. And then we'll place them in there, just like that. Just like that. Just like that. There we go. Very dense. That's actually kind of heavy with all 4 of those capacitors on there. Like I said, if those are really 8 watts for 2 of them, this whole thing can hold like, well, can sustain, 16 watts for a full second. It's kind of a lot of power when you think about it, especially if you were to say 1/10 of a second, 160 watts. In a little bit, we're going to do some sparking. I'm going to charge these up, and we'll be able to see what kind of energy that many joules is. 2, 3. There we go. Oh yeah, soldering up just like a dream. Eagle footprint is good. And we are almost ready to test. It's looking good. Yes. There we go. So once again, here's the old version, and here's the new version. Notice the old one used 3,300 microfarad capacitors. We got 4,700s here. Extra power capacity. So, oh, there's one other feature of this board I want to take care of while we're here. This board has the capability to connect the 2 halves in series. Well, why would you want to do that? That is so, remember I said that for these kind of instruments, having a high voltage is always really, really beneficial. It makes the circuit more efficient. It lets you reach higher power levels without having a charge pump and stuff like that. This jumper here lets you actually enable the board to put the 2 sides in series, so you get the two voltages. So you might have 16 voltages on each. Bam, now it goes up to 32 volts. So 32 volts will drive an amplifier a lot better, like a simple amplifier, a lot better than 16 volts will. If you're talking charge pumps and other things, then there's an exception to that. But those things reduce your efficiency a little, and they make the circuit more complex. So I say, why not just connect these two things in series? It's an option. There's just a little header on there. You can put a shunt it and connect the two halves. Then we totally gutsy. We could just throw it right into right into an instrument. But I don't have an instrument set up here right now. So what we're instead going to do is just hook it up to the generator itself, and then look on the meter and see if we get any electricities going into it. So I'm going to get my handy dandy multi 4-in-1 screwdriver. I love these. I use these so much. Whoa, there goes the tip. Hang on. Okay, let's just make sure. What's the right size for these? Okay, that's it there. So I'm going to open these up a little bit, all these terminals. Do that, you just put the screwdriver in, unscrew. That's all it takes. Okay, I've already attached some extension wires to this thing. Let's put in the first pair here. So there's this moment of anticipation here. You never know if something's going to work the first time. But I like doing this live. Because you don't know if it's going to work. I don't know if it's going to work. That's the first half of the stepper motor. Now I'm going to connect the second half. Baby. Get those straight. There we go. That took a moment. Okay, at this moment we're live, meaning that we could potentially see some electricity coming out of there. So I've got my meter here. Let's try and put this so that you can see it as well. A random idea. Just put it right into the vise there. Hopefully you can see that says 0 volts right now. So I'm going to take my alligator clips. I'm going to attach and now I'm going to take the other end of these clips and I'm going to put it onto the circuit board, onto the plus terminals. I'm just going to go directly to these as opposed to trying to go into the jumpers right now. That's going to be a little bit of a challenge. Okay, whoop, almost on there. Okay, there we go. So obviously we've got 0 volts. And all I have to do is drive this generator. Do you want to take any bets on whether this is going to work or not? What are the odds? 50-50? 10-1? I don't know. But here we go. Let's let it rip. Oh, yeah. Look at that. Just like that. 15 volts appearing. That is what you want to see. So if anyone at home wants to do the voltage, the joules calculation, 1/2 CV squared, then that's your V, and we know that C is 4,700 microfarads. Also notice that it's fading away slowly. It was 14 volts before, now it's already 13. That's because of the equivalent series resistance of the capacitors. So they have some resistance inside them. So when you buy capacitors, you also want to buy capacitors with the smallest ESR, or equivalent series resistance, in there. No problem though, we'll just charge it again. Whee! Oh yeah, and that 1 means we've overloaded the 20 volt scale. So like I said, these things can get kind of high voltage. So now we got to go to the 200 volt scale, and I'm really going to crank this thing. Whoa! The belt fell off. Before the belt fell off, what did we get to? All right, 22 volts, 28 volts, 29, 30. Okay, so we saw 32 volts peak. That's pretty exciting. But check this out.
Who do I talk to get stepped up on these 3D printers one of these days?
Oh, Dan Fiskelmans.
Dan?
Yeah,
All right.
or Kyle. Kyle Rivers.
Dan or Kyle.
Yep.
Cool, thank you.
Yep. So here we go. All right, so this, don't forget these capacitors are charged up, so they got a lot of power in there. So where does that power go when you short it? Whew, nice little spark. And the other side is sparking too. It should. Whew. Oh my God, okay, that wasn't totally, whew. Totally safe there. Little 6-inch sparks, I hope that came out. Anyway, that is pretty much it. So just in about, let's see, 26 minutes, we went from totally empty board like this and a bunch of components to a working voltage doubling rectifier. So I think I'm going to build up the other two of these, and if you have any questions, post them in the comments. You want to know how this stuff works, where to get the components, what the schematic looks like, all kinds of technical stuff and musical stuff. I can totally answer that. All right, thanks for tuning in, and we'll see you in the next live or non-live video online.